So I noticed that from the last video, there's a little bit of cutoff at the end. So this is where we are right now. So if you calculate your friction, let me quickly finish this one. So if you calculate your friction, it should be about 23.9 Newton. Okay, so you can double check those calculations later on. So basically, that answers part A, which is what is your friction? There we go, 23.9. Now, to part 2, which is find its acceleration. So now we look at friction, and we go, okay, so friction is 22.9. The applied force is, well, how much? So let's look for it. Applied force is actually 45. So who wins, right? Applied force wins in this case. So we basically set up a net force equation, and we say F flat is equal to MA. F flat is equal to MA later on. But at the beginning, we say F flat is equal to applied force minus friction because applied force is winning. So if you take the 2 and then you make it equal to MA. So that is the equation that we have to use. So F flat equal to winner minus the losing side and equal to MA. So now everything should be ready. So we have applied force, which is 45 Newton. So 45. And then we have friction, which is 23.9. And we have the mass of the box, which is 3.75 kilogram. And we're looking for acceleration. So some magical stuff later, you get the acceleration at 5.63 meter per second square. Okay, now since I don't know the direction for this one because they didn't say which way they're pushing the box, I randomly say it's right hand side, but that's my guess. There we go. So that's your acceleration. Okay, pretty easy, right? For the first example. All right, so you can pause the video right now to make sure that you copy down everything, but we're gonna move on because I do have a 10-minute limit for each segment. So I have to make sure that I don't want it to cut off like the last time, basically. So another question, a 0.2 kilogram puck is pushed along a sheet of ice with a force of 0.24 Newton. If it moves at a constant velocity, find the coefficient of friction. Okay, so again, start by free body diagram. Gravity, normal force, friction force, and, actually I will put a pi force on this side. Just a habit for me, to put a pi force on the right hand side and friction on the left. But okay, so this is the picture right now. Okay, so procedures, right? Almost the same. We start with the y direction. We get gravity first, which equals to mg. And in this case, gravity is, mass is 0.2. So therefore, we can get that quite easily. It's going to be about 1.96 Newton. Okay, so, and then we also say Fn must be mg. So normal force should be the same because, again, this object is not going to move up and down. It's sitting on a, ice table or something like that, right? So the normal force and the force of gravity should be the same and canceling out. So we say that they are exactly the same value. Okay, so then once we have that, we can find out what friction is. So we say, therefore, friction must be mu Fn. Well, but then here's the problem. We don't have mu. So, we need something else. Like we have normal force now, but we don't have mu. So we can say, normal force is 1.96, which goes in here, but I need friction from another way. So we're going to look at the x direction then. So looking at the x direction, I can say that my applied force is, in this case, equal to my pulse of friction. And the reason why is because of that very last sentence in this question. the coefficient of friction in here is, well, the coefficient of friction in here must be something that we can find knowing that we have constant velocity. Now, constant velocity means you don't have acceleration. If you don't have acceleration, that means all the forces cancel out. Not only the vertical one, but the horizontal one also canceling out. So because it's a constant velocity, well, I would say a pi force and friction just, tie each other. No one is winning. So therefore, because they give me a pi force, I can also, well, then I can find friction. So I can say friction is equal to 0.24 Newton, which is what they give you for a pi force. Wait a second, but now we have this thing. So we suddenly have friction, which you can put it in here. And we have normal force. So now looking for mu is no longer a big problem. So solving for mu. Mu is going to be friction dividing by normal force, which in this case, it will just be 0.24 divided by 1.96. And ladies and gentlemen, we are now done with this question. So there you go. So 0.122, that is the friction, coefficient of friction on this ice and puck interface. So one side is ice, the other side is the hockey puck. Okay, so then we are done. So this question is now complete. Okay, so I'm going to stop the video right now because, again, I don't want it to cut off like midway through. But then, so watch the next video